All right, so here are the second set of notes for Math of Personal Finance Term 1. Today we are talking about savings accounts, and there is a lot of vocabulary words here for you. I went ahead and wrote down the definitions. I would suggest that you pause the video right now, write down these definitions on your own paper, and then continue the video and we can talk about it a little bit more. But a couple of things that I want to point out. So a savings account, that's what we're talking about today. The nice thing about a savings account is the bank pays you interest, which means based on how much money you have in your account, the bank is going to give you a small percentage of that money deposited into your savings account each month or each year, depending on the account. I will say they don't normally give you a very big percentage. Like my savings account earns like cents every month. A money market account has a higher interest rate, but it's going to require a higher initial deposit. So you have to have a lot of money in your money market account first, keep that money in there, and then you'll get a higher return on that money. A higher interest rate will be paid to you because you are depositing more money into that account. Now a CD, this is probably my favorite form of savings. It is guaranteed money. Okay, it's not like stocks. It's not like depending on how things go. It's, hey, this is the agreement. You give us this much money for this long. We get to keep that money. And then at the end, we will give you a fixed interest rate based on that money. Now, there's a couple of things. You've got to kind of like watch it. Make sure you take it out when your money is like has matured. Otherwise, they're just going to re-enroll your money into a different CD, and that's probably going to be at a smaller interest rate than the one that you initially signed up for. So that's kind of a little, note right there with CDs, but I love CDs. I think it's a great way to save money without risking money. Minimum balance is just the smallest amount of money that must stay in your account. So a lot of times savings accounts, definitely money market accounts, are going to require a minimum balance. You've got to have that much money in there or you're going to get a fee or you won't get your interest earned or something like that. FDIC, that acronym stands for Federal Deposit Insurance Corporation. And what that is it's insurance that the money in your bank is safe. Okay, it's not like Great Depression times. The money is now safe based on FDIC. Okay, so simple interest versus compound interest. We're going to talk about interest a lot this term. Today we're going to mostly focus on simple interest. And then I think in the next lesson, or maybe the one after that, we start talking about compound interest. So simple interest, you earn interest on the original deposit. So you put $500 into this account, you're going to earn a percentage of that $500 because that's how much money you put in. Now, compound interest is different. Compound interest, you earn interest on that original deposit and all of the interest earned. So say I put $500 into an account, I'm going to earn interest on that amount of money. And after the next month, I'm not just earning interest on the $500 that I originally deposited. I'm earning interest on how much money is now in my account with the interest added in. So if I earned $5 in interest that first month, then the second month, I'm going to earn interest not just on $500 with simple interest, but on $505 this time because my interest will be compounded and it'll keep growing and growing and growing. APR stands for annual percentage rate, and this is a yearly rate paid by the bank. And it's going to be paid in I'm going to add this in. This is a percentage. Okay, so APR, that's your percentage rate. All right, so there's all of the vocabulary for today's lesson. Now we're going to look at our first formula. So this is the formula for simple interest. Okay, that's what we're talking about today. Remember, for simple interest, you are only earning interest on the original deposit. So the formula for simple interest is I equals PRT. Now let's talk about what's happening in that formula. Okay, the I stands for your interest. Your interest earned. So like how much money you're earning in this savings account. Now the P, R, and T, want to point out that those three things are being multiplied together. Okay, it's like P multiplied by R multiplied by T. So the operation happening between these letters is multiplication. Now let's talk about what each of the letters stand for. So P, that is the principal. And principal is your original deposit. It's how much money you start with. Okay, it's how much money you're going to deposit into your account. That's the principal. R is the rate, okay, like your annual percentage rate. And remember, this is going to be a percent. When you plug it into your formula, you have to switch it to a decimal. So you've got to switch it to decimal form first before you plug it into your formula. And we'll practice that. And then the last one, T, stands for time. Now this is time measured in years. So it's how many years have gone by. That's what the T is. All right, let's use that formula. Actually, we're not going to use that formula just yet. We will on the next one. But let's look at this first example. So it says, Grace wants to deposit $5,000 into a certificate of deposit, a CD, for a period of 2 years. She is comparing interest rates quoted by 3 local banks and 1 online bank. Write the interest rate in ascending order. Which bank pays the highest interest for this 2-year CD? Okay, so she's got her $5,000. She's going to put it in a CD, and obviously she wants to put it in the CD that's going to give us the highest interest rate because that'll give her the most amount of money after the 2 years. So our goal right now is we're going to compare these 4 different quotes. These 4 different banks all have different interest rates, and we want to see which one's the biggest. We are supposed to write these in ascending order, so that means we're going to start with the smallest, and then we're going to go to the biggest. Okay, now some of these percentages are written in decimal form, and some of them are written in fraction form. To compare them, let's put them all in the same form. The easiest way to do that would be to switch all of these so that it's like a decimal, okay? So First State Bank quoted her at 1 1/4%. So that 1 1/4, that's going to be 1 point. Now 1/4 I know is 0.25. If you don't know that that's 0.25, that's totally fine. Grab your calculator. There's a little fraction button on it. It looks like this. So N/D. If you push that button on your calculator, then you can type in that fraction, and you're going to put 1/4 and then hit enter. And it's probably going to tell you, hey, that's 1/4. To switch 1/4 to a decimal, you want to hit this button. It's kind of got like little arrows on both sides, and then it will tell you that that's 0.25. So we will know that that's 1.25. Okay, so that's First State Bank. And if you need help with your calculator, totally feel free, pause your video, raise your hand. I'll come over and help you right now. Okay, next one, the eSave Bank. They quoted her 1 3/8%. So that would be 1 point and 3/8. I honestly don't have that memorized. My husband would be able to tell you in a heartbeat, but I can't. So I would use that calculator thing. This time I would type 3/8. Hit enter. Probably going to do that 3/8 thing again. Push the decimal button. And this time it would give you 0.375. So that would be 1.375%. Now the last two, fortunately for us, are already just like in decimal form. Now I don't have to like move the decimal because all of these are percents. So I'm just going to keep them all as percents. They're already percentages, so we'll just keep them. And now we're going to write this smallest to biggest. So as I compare the numbers, they all have 1. It's all 1 point something. So far they're all the same size. Then I'm going to look at the next digit. I've got 1.2, 1.3, 1.2 again, and 1.3. So 2 is smaller than 3. So I'm going to look at the next digit for these first two. Well, I don't know, the ones on the left. For First State Bank, it's 1.25. Johnson City Trust is 1.22. So 0.22 is smaller than 0.25 because 2 is smaller than 5. So my first bank that I'm going to write down is the Johnson City Trust, because 1.22 is my smallest number. Next, it will be that First State Bank. Okay, and now I'm going to look at the 1.3s. So eSave is 1.37. And the Land Savings Bank is 1.3 flat. There's not anything after that 3, so it's a 0. 0.30 is smaller than 0.37. So the Land Savings Bank, 1.3% is my next biggest. And then the biggest would be the 1.375 eSave Bank. So there's the interest rates in ascending order, smallest to biggest. So which place should she invest? eSave. The eSave Bank will give her the best interest rate, most amount of money after 2 years. All right, next example number 2. How much simple interest is earned on $4,000 in 3.5 years at an interest rate of 1.2%? Here's our formula. Okay, so for these formulas, I'm just going to write down all of the letters. Remember, I is our interest earned. We don't know that. We're trying to figure out how much interest is earned. So this is a question. We don't know how much I is. P, that's our principal, our starting amount. How much interest is earned on $4,000? That's how much money we are investing. So 4,000 is our P value. R, what's the interest rate? It says our interest rate is 1.2%. Okay, now remember 1.2%, I've got to switch it in decimal form. So when I convert that to a decimal, we talked about this in the last unit, we are going to divide 1.2 by 100 or shift the decimal 2 places to the left. That will be 0.012. That's our R value. And then T, time, it says it's 3.5 years. So 3 1/2, you can keep it as a fraction, or you could write that as 3.5. Those mean the same thing. Okay, now we got all of our values ready. We're going to plug it into our formula. So we're going to figure out what does I equal. So our interest rate equals P, which is 4,000. I'm going to plug these numbers into my formula, times R, which is 0.012, times T, which is 3.5. Okay, now what is happening with each of these values? These are being multiplied. It's 4,000 times 0.012 times 3.5, because this formula, those letters are being multiplied together. So to find our answer, you're just going to type in your calculator. What's 4,000 times 0.012 times 3.5? And your calculator will tell you that that equals 168. So the I, the interest earned, is $168. You deposit $4,000 into an account at that interest rate for that long, and you will have earned $168. Example 2. Raul's savings account must have at least $500 in it, or he is charged a monthly $4 fee. His balance was $716.23 when he withdrew, so took out $225. What was his balance after the withdrawal? Okay, so he's starting with this $716. Okay, that's how much money he's starting with. and then he withdrew $225. So when he takes out that $225, he's going to subtract $225 from the amount in his account. After he does that, he will be left with, so if you take those numbers, you perform the subtraction, go ahead and type it in your calculator, that would be 491.23. So that's how much money he has in his account now. Now the question asks, what was his balance after withdrawal? Now the problem is, he's not just going to have $491.23 in his account, because he does not have at least $500. So he's going to get charged a $4 fee. So because this number is below, it's less than the $500 minimum, he's going to get charged the $4 fee. So we're going to have to subtract $4 from that number. When we do that, we will get 487.23. That number will be how much money is actually in his account. So he started with $716.23, took out $225. He's now below the minimum. He gets charged a $4 fee, and that is his ending balance in his account after that withdrawal. Okay, next example. Mitchell deposits $1,200 in an account that pays 1.5% simple interest. He keeps the money in the account for 3 years without any deposits or withdrawals. How much is in the account after 3 years? All right, we got our formula right here. Let's talk about what I equals. I, remember, is the interest earned. We don't know how much interest he's earned yet. That's a question mark. We're going to find that. P, the principal, the starting amount. How much money does he deposit into this account? $1,200. So that would be our P value. The interest rate, R, is 1.5%. Remember, we have to change this to decimal form though. Divide by 100 or move the decimal 2 places to the left. 1.5% as a decimal would be 0.015. And T, his time that he's going to leave this in account, 3 years. So T equals 3. So I'm going to plug it in. I equals the principal, 1,200, times the interest rate, 0.015, times the time, which is 3. Remember, we're multiplying each of these numbers because that's what our formula says to do. So when you multiply those together with your calculator, you should find that the interest earned is $54. Okay, so he's earned $54. The question in this problem, though, asks us, how much is in the account after 3 years? Does he have $54 in the account after 3 years? I would hope not, because he deposited $1,200. If he deposits $1,200 and after 3 years of earning interest, he only has $54, that is bad news. Something bad happened. So that's not just our answer. His interest earned is $54. But his amount in the account remember, it has the original $1,200 that he deposited and the $54 that he's earned in interest. So you're going to add those together. $1,200 plus 54, he has $1,254 in his account. That sounds a lot better. So he started with $1,200. He earned $54 in interest. So now in his account, he has $1,254. So when you're doing these problems, always make sure you read the question and you identify what are they actually asking me. Make sure you answered the question that was asked because it's different sometimes. Okay, next example. How much simple interest does $2,000 earn in 7 months at an interest rate of 2%? Round your answer to the nearest cent. That's typically how we round. We want to write our answers like dollars and cents. So cent would be like point, decimal point, and then 2 numbers after the decimal. All right, so in our formula, we don't know how much interest is earned again, so this is a question mark. The principal, our starting amount P, is $2,000. And R, the interest rate, let's see, it told us interest rate of 2%. Switch it to decimal form. So this will be 0.02. That's the number we're going to use in our formula. And T, our time, this is where it's a little bit tricky. 7 months. Remember, time is measured in years. So I can't just say 7. 7 months is not 7 years. This is 7 months out of 12 whole months are in a year. So what I'm actually going to do for my time is use the fraction 7/12. I would probably just keep it as 7/12 because if you plug that in your calculator and try and write as a decimal, you get 0.58333333. 7/12 is a lot easier to work with. So let's plug in 7/12. That's totally fine. Okay, so now I got my values ready. So in my formula, I equals the principal, 2,000 times the interest rate, 0.02 times the time, 7/12, because it was 7 months out of a whole year. There's 12 months in a year, so 7/12 is what I'm going to use. Now, when you plug that in your calculator, again, you're going to have to use that little N over D button for the 7/12. And I can help you with that if you need me to. So plug that in your calculator, and we should get I equals 23.33 if we round to the nearest cent. So again, remember, we're going to keep 2 numbers after the decimal point, so 0.33. And this question, how much simple interest is earned? That's our answer. Kind of covered up my solution over here, but we would put $23.33 as our solution. Okay, next example. Derek has a bank account that pays 2.1% simple interest. The balance is $910. When will the account grow to $1,000? We want to round this to the nearest month. Okay, so this one is a little bit interesting because we want to know when will the account grow to $1,000. So if he starts with $910 and we want it to grow to $1,000, the interest earned is going to be the difference between those two numbers. So if you take 1,000 minus 910, that equals 90. The interest earned has to be $90 to start with a balance of 910 and it grow to $1,000. You have to earn $90 in interest. So this time we actually know what I equals. We know what I would have to be. It'd have to be 90. We also know what P equals, the principal. That's how much money we're starting with. So that's 910. The interest rate is 2.1%. As a decimal, that would be 0.021. And the time is actually what we're looking for. That's a question. We want to know when will the account grow? That's what we're searching for. We're going to solve this formula to figure out what T equals. So the formula says I equals, and normally I've been writing I, but this time I know what I equals. I is 90. So it will be 90 equals P, our principal, is 910 times R, 0.21 times T. And this time I don't know what T is. So I'm just going to put T into my formula. Now, as I'm solving this, I cannot multiply 910 times 0.21 times T, but I can multiply these two numbers. 910 times 0.21, plug that into your calculator, you should get 19.11. And then the T is still there. And that would equal 90. So I'm using my solving equation skills right here. I want to solve this equation, see the equal sign, to get T by itself. So right now, it's 19.11 T. Remember, the operation that's happening between these is multiplication. So how do I undo multiplication? Divide. I'm going to divide both sides of this equation by 19.11. Now, when you're solving an equation, if you divide one side by 19.11, you got to keep it balanced. You also have to divide the other side of the equation by 19.11. Now, when I do that, go ahead and plug this into your calculator. What is 90 divided by 19.11? It is 4.7096. There might be more numbers after that, I can't remember. And that's going to equal, now 19.11 divided by 19.11 is 1. That's going to reduce down to 1. T. The T is still there. That's my answer. T equals 4.7096. Now, my answer is not just that number, because my instructions were to round to the nearest month. Oh, sorry, it kind of got crazy there. There we go. Okay, round to the nearest month. Okay, so the 4 is a whole number. That stands for, remember, time is measured in years. So that is 4 whole years. Now, the 0.7096 is some portion of a year. It's some amount of months. Now, because there are not 10 months in a year, there's 12. It's not just 7 months. What I need to do, though, is take that 0.7096, and remember how I said it's not just 10 months in a year, it's 12. Because there are 12 months in a year, I'm going to multiply that number by 12, and that'll end up telling me how many months is this actually. So if you multiply those two things together, you'll get 8.5-ish. There's a little bit more after that. So what that means is this is 8 months and a few weeks, right? It's 8.5 months. So if we round to the nearest month, his interest is not going to have quite earned him $90 after 8 months. We're going to round up to 9 months because we've got to go finish up that month. So the answer here would be 4 years and 9 months. That's how long it takes his deposit of $910 to grow to $1,000. It would take 4 years and 9 months for that to happen. Okay, I think this is our last example for this video. Carrie invests $5,000 in a simple interest account for 5 years. What interest rate must the account pay so there is $6,000 at the end of the 5 years? So for our interest rate, we want there to be $6,000 at the end of the 5 years. Remember, she's starting with $5,000. So if we want $6,000 and we're starting with $5,000, then we have to find the difference between those two numbers. 6,000 minus 5,000 is 1,000. She has to earn $1,000 in interest to get to the $6,000. So our I equals 1,000. Now P, remember that's the principal. We're starting with how much money she invests. So P is 5,000. R, our interest rate, we don't know. We're trying to figure out what our interest rate is. That's what we're looking for. T, time in years. after 5 years, so t will equal 5. All right, now let's plug in our formula. So instead of I equals, I'm going to have 1,000 equals P, which is 5,000, times R, I don't know what that is, so I'm just going to write an R, times T, which is 5. So the first thing I'm going to do is go ahead and multiply 5,000 by 5. 5,000 times 5 is 25,000. So I'll have 25,000 R equals 1,000. Now, when I'm solving this equation to get R by itself, I want to get rid of that 25,000. It's being multiplied by R right now. Opposite of multiplication is division. So I'm going to divide by 25,000, and I've got to do that on both sides of my equation. Now, 1,000 divided by 25,000 is 0.04. On the right side, 25,000 divided by 25,000 is just 1. So I will have 1 R. So R equals 0.04. Now, R is a percentage, right? It's an interest rate. So what we're going to do this time is actually switch it back to percent form. So you can multiply by 100 or shift our decimal 2 places to the right. 0.04 is 4%. So what interest rate must the account pay? It must pay 4% to start with 5,000, grow to 6,000 at the end of 5 years. All right, you should be ready to do your practice problems.